Welcome to the second of 8 brief discussions on the high leverage practices from the book Principles to Action. This is practice number 2, implement tasks that promote reasoning and problem solving. In this lesson, we will define teaching practice 2 of the Principles to Actions. We'll consider the best practices for teachers, and we'll connect practice 2 to the Danielson framework for teaching. Again, this comes from the book Principles to Actions from the National Council of Teachers of Mathematics, and we'll discuss practice 2. If you'd like to read through all 8 of these practices, you may pause the recording. The Idaho Mathematics Instructional Framework is a modified version of the 8 high leverage practices from the book Principles to Action. This would be practice 2 of the Idaho Mathematics Instructional Framework, engage students in high-level thinking through challenging mathematical tasks. When you think of the math classes you grew up with, it probably looked similar to my high school math classes. The teacher gave us something to work on when we came in. We graded homework. The teacher showed us what we were learning and demonstrated some examples. We as the students then tried some examples, and then we all kind of went over it together. It was the I do, we do, you do model. The teacher then repeats the process, or we're given lots of time to practice using a worksheet like the one shown here, where we perform the operation and do it multiple times. Does this sound familiar? I recently went into a math classroom that went exactly as I just described. Many math teachers even hold their boringness as a badge of honor. You cannot fault teachers for teaching the way they were taught. They loved the way they were taught, or else they wouldn't have gone into teaching. At the same time, research shows that we can and must do better. Traditional math teaching was a form of mimicking. The teacher wanted the students to mimic what the teacher does. Mimicking can produce short-term, replicative routines. Any host of math formulas or concepts can be taught as a mimic. For example, slope. If you look at the graph, a common question would be, can you find the slope of the graph? There's an equation that teachers use to find slope. They find 2 points on the line. They label them as x1 and y1 and x2 and y2. Then the procedure is you do y2 minus y1 over x2 minus x1. The teacher can reasonably teach this math standard by showing the students a procedure. They may even dabble in explaining the concept, but focus predominantly on the procedure, how to do it, and miss teaching the main concept. Namely, that slope is a ratio of how much the y value and the x value are changing. If slope is a ratio, then we can apply it more readily to situations outside of abstract math. For example, how much money we're making over hours worked, right? The ratio of those 2 variables. So if we focus on a concept versus a procedure, students are more likely to remember and recall those things. In the book Building Thinking Classrooms by Peter Liljedahl, which I highly recommend as a book study, the author, Peter, commits a chapter on tasks that promote thinking. He addresses the traditional mimic style of teaching mathematics. Quote, mimicking tends to create short-term success without long-term learning that allows students to make connections with other topics. Mimicking happens not alongside, but instead of thinking. Likewise, mimicking is not a precursor to thinking. As a teacher feels pressed for time, they may revert to mimicking because it is quick and in the short term effective, but with little, if any, long-term understanding of the concepts mimicked. We do not serve our students by teaching them to mimic their teachers. This can be one of the contributors to students doing great in elementary K4, but then bombing 5th grade and subsequent grades. check your elementary's ISAT scores if you don't believe me. The students did not get a deep understanding of the concepts. The teacher showed them algorithms or procedures without conceptual understanding that comes with thinking. So why are we talking about procedural and conceptual understanding? Well, the easiest way to have teachers teach conceptually versus procedurally is with tasks. Tasks should primarily focus on the concept, not the procedure. Going back to our example of finding slope of an equation, students should spend their time understanding slope as a rate of change. We won't be able to go into depth about what that looks like in this conversation, but the key idea is that time should be spent more with conceptual understanding and less on procedural. Take just a minute and look at this example. This is from the website Open Middle, and this is a task for students. Pause the video, look at the task, and then when you're ready, press play. As students are taught more about the concept, they'll be able to be assessed at a higher level. This is a task to see if they understand the concept of their equations. If you've read through it, you can see that they're asked to make 5 ordered pairs that make a greater rate of change. Rate of change meaning slope, right? If the students understand slope, they understand rate of change, then they should be able to be pushed and challenged using this task. Here's one more example to reiterate this point. On the left is a worksheet that demonstrates what most textbooks will have. That is, they'll be written in a mimic style format. You cannot fault teachers for teaching in a mimic style format if their curriculum is written that way. Remember that mimicking is not thinking. On the right is a deeper level task related to the worksheet on the left, and teaching and training to move from mimicking procedural learning to conceptual learning is difficult if their curriculum is written entirely in a mimic format. The good news is that when teachers are provided with rich curricular tasks, they will generally transition and train very quickly to a conceptual focus. Again, I'm sorry for this, but here is the main point. Tasks that promote reasoning and problem solving should be focused on conceptual over procedural problems. We often see students solving procedural problems and think, wow, look at all that problem solving. That's not what this specific practice is talking about, that they can solve problems that are rote, that the teacher's shown them how to do. That's not what promotes reasoning and problem solving. When we talk about students learning concepts and applying those concepts to new situations, that's when we have conceptual understanding. If you look at Danielson's domains 1 and 3, you can see how choosing tasks could be reasonably justified in multiple components. Pause the video for a minute to reflect on all the components that choosing tasks could fall under. Then press play when you're ready to continue. Here are just a few examples of what we could reasonably justify, though we could arguably justify probably all of them. Applying knowledge of content and pedagogy, understanding conceptual versus procedural, setting instructional outcomes of problem solving, using resources effectively, which if their curriculum's not built with conceptual activities, they're going to have to go find those, or they're going to have to repackage what the students are learning. That they won't just be able to follow the same examples the book has. This is particularly evident in the secondary level. of books being very procedurally driven. Planning coherent instruction, using questioning and discussion techniques, engaging students in learning. Students will engage more when the teacher is helping them conceptually understand because they're thinking. A lot of times when you go into a classroom and the students are mimicking the teacher, here's how you do the problem, here's how you find slope, right? That is not intellectual engagement. That's not thinking. And so designing and creating tasks that engage students in learning comes from conceptual based tasks where the students are using their own reasoning, using their own problem solving, as opposed to doing what the teacher wanted them to do in the exact way they wanted them to do it. Additionally, if you're going to teach conceptually, you're going to get a lot more thoughts, ideas from the students, and you need to be able to respond flexibly to those students. This diagram is from the National Council of Supervisors of Mathematics book called Instructional Leadership in Mathematics Education. This shows the progression of implementing tasks that promote reasoning and problem solving. Take a moment, pause the video, and read over the progression. Press play when you're ready to continue. One aspect we haven't discussed in detail, but does deserve its own conversation, and we'll talk about in later videos, is the phrase in the third column that says lens to multiple entry points and solution pathways. Briefly, multiple entry points means that students are able to access the problem based on their current knowledge understanding. These tasks are called low floor, high ceiling tasks. Perhaps we can discuss this later. Additionally, there is a myth in our society about mathematics in general. That is, that there is only one way to solve a problem. As my wife says, when she was in math, just give me the formula and show me what to do. While formulas can be helpful, we pigeonhole everyone into solving a math problem that one way, using the formula. That is a mistake in how we have been teaching math. Both of these topics can be discussed a little bit more later in depth at a later time. This concludes our discussion of High Leverage Instructional Practice 2 from the book Principles to Action, Implementing Tasks that Promote Reasoning and Problem Solving. Also, this relates to the Idaho Mathematics Instructional Framework Practice 2, Engage Students in High-Level Thinking through Challenging Mathematical Tasks. One thing I want to say here, high-level thinking, again, we're talking about thinking. Mimicking does not belong in high-level thinking. As a reminder, this is the process for the Accelerated Learning Program for administrators. I've made a few adjustments you might be able to see. In November, we'll do a few walkthroughs focused on communicating learning goals and implementing tasks. If you have any questions, thoughts, or comments, please reach out to me. This is my personal email and cell phone.